Okay, so the solving by the square root property, that's our second method. Remember I said we had 4 methods. So, and if you're thinking, well, I'll just always use factoring. The problem is that's not always going to work. Not everything's factorable. So, sorry. Okay, so we're going to show you how to solve by the square root property. Okay, so first you look here at this problem, and it says solve by the square root property, so it must work. We see that we have an x squared term, right? 3x squared. So I need that 15 to be on the other side. So I'm going to say 3x squared equals 15. I'm just adding the 15, just moving it to the other side and changing its sign. Okay, then I'm going to divide by 3. I want to get the squared part by itself. So x squared equals 5. Then I'm going to take the square root of both sides. Now comes the square root property. So I'm going to take the square root of this side, and I'm going to take the square root of this side. Don't forget the plus or minus. So what solutions do I get? I get x equals plus or minus the square root of 5. That's fine. Now notice this time, well, 5 you couldn't take the square root of. It's some irrational number. You can get a decimal approximation on a calculator. You can write it in set notation as the opposite of the square root of 5, or just the square root of 5, like that. Probably one of those two methods is what WebAssign will probably want. Okay, or you can write them just separately. All right, let's look at another one. And all of these problems are different. They're all good examples. Okay, it's set up similar, right, to the last problem. We've got the x squared term, so let's get the 25 on the other side. That's going to have 9x squared equals negative 25, right? Because when we move it to the other side, we're subtracting 25 here. Okay, so that makes it negative 25. And now if you're thinking divide by 9, great idea. Divide by 9. And so I have x squared equals negative 25 over 9. Great. I have the x squared part by itself. I'm going to take the square root of both sides. And I don't forget the plus or minus. I'm going to say that probably on every one of these problems because I don't want you to forget. Okay, now we have a little situation, right? This is negative. So what does that mean? It means there's going to be an I involved. So on the left-hand side, I'm going to have x. But over here, I'm going to have plus or minus I. And then I'm just going to write the square root of 25 over 9. So all I'm doing is I'm taking care of the negative sign right there. Because there's a negative under the radical, that means I'll have an I. Notice where I place the I. The plus or minus, then the I, and then this radical part. But this radical part actually simplifies. I know the square root of 25 and I know the square root of 9. So remember we have a property that says we can split that up. The quotient property. And so I'm going to get 5 over 3, right? Okay, so what does my final answer look like? Well, it looks like this. X equals plus or minus 5/3 I. If I want to write them separately, it's going to be a negative 5/3 I and a positive 5/3 I. Is there a reason I always put the negative one in front? That's what they usually do, but I'm not super picky on that either. Okay, hopefully that all makes some sense. A lot going on in that one. So we can have imaginary solutions. This is the first one where we had that, but we can do that. All right. So we have one more problem here. Notice that we have this binomial being squared. Well, this time we're not going to multiply it out. We don't want to square it out. That's going to be more work. We want to just apply the square root principle right now. So we want to take the square root of this side, and we want to take the square root of this side. Don't forget the plus or minus. Okay, so now what I have is I have x minus 2. I don't really need the parentheses, but I put them. And then on the right-hand side, we have plus or minus the square root of 6. Okay, so let's talk a little bit about this. Here, the square root part and the square, those are inverse functions, and so they undo each other, right? You square something and you undo it. We have a property somewhere that says the square root of a squared is equal to a, if it's positive, and you can say plus or minus a. I don't know. That's not helping. Okay. But that's true. Okay. Why do I put the plus or minus on this side? Well, that's where my solutions are going to pop up. Okay. So I think I've talked too long on this, making it too hard. Okay. I almost have x solved. Remember, the goal is to get x by itself. But what I want to do is I want to add 2. Now, where do I put that 2? It'll come in front of the plus or minus. So the answers are going to be 2 plus or minus the square root of 6. If you're writing them separately, 2 minus the square root of 6 and 2 plus the square root of 6. Okay, so these are fine answers right here, one of those ways. That's tricky when you're adding this 2 over. It has to go in front of the plus or minus. And you can say, well, why can't I put it at the back? We just don't normally do that. It makes it a little bit harder to read, and we want that radical. We want to make sure we know what the radical is. I also forgot to talk about, hey, what about that 6? Does that simplify? Can I break that down? Well, 2 times 3 is 6. That's the prime factorization. And so, no, I don't get any pairs. It's just the square root of 6. So my answers are 2 minus the square root of 6 and 2 plus the square root of 6. Those are real numbers, and you can put them in a calculator to get an approximation.